Hello everyone, in this video we're going to be looking at how we can calculate the size of a directory in our file system. So, calculating the total size of an entire directory tree. So we're not just going to see what files are in a directory and add the file sizes together. What we need to do is if there are subfolders, we need to calculate their size as well. So the way we're going to do this is using recursion. So we're going to open up a directory, add up the total file sizes of all the files, but if one of the files is a subdirectory, then we're going to recurse down into that and work out its size as well. And this continues until we get all the way to the end of the tree. So that's what we're doing in this video, and we're also going to test it to see if it actually works. So, over in Eclipse, I've created a new project called Directory Size, and I've created a new class inside this project called Directory Size as well. So the first thing we're going to do is right up the top, import some files. So java.io.file and util.scanner. Okay. So they're the only two files we need to import. How we're going to do this is we're going to create a method called getSize. So this is going to look like the following. Public static long getSize, and its parameter is actually going to be a file, which is a handle to a directory. Remember that, or a directory or a file, I should say. The file object is also used to represent directories. The Java makes no real difference between them. So file, the object, or the class is used for both files and directories. So just keep that in mind. So, first thing we're going to do, now that I've said that, is, well, if it is a directory, then we need to add up all the files that it contains. So if the file is a directory, that method makes things a lot easier for us. Then what are we going to do? Well, we're going to get all the files that this directory contains, and this is going to be a file array, and we'll call it files equal, and the way we do this is with file.list files. There we go. Okay. Now what we're going to do is iterate over each of the files and add their size together. So actually what we need is a variable to store the size. So what we might do is right up the top of this method, declare a long and call it size and initialize it to 0. So back down here, for int I equals 0, I less than files.length I++. So looping over each of the files, all we're going to do is add on the current size of our file. And the way we're going to do this is by recursively calling this getSize method. That way, files and directories are handled in the exact same way. So, getSize files at index I. And really, that's the main part of this all done. But what if it isn't a directory? In other words, what if it's just a regular file? Well, in that case, we have no files, we have no contents to loop over. All we need to do is get the length of this file and add it on. So, else, if it's not a file, sorry, if it's not a directory, size plus equals file.length. And really, that's all there is to it. We should probably return size. And that's amazingly simple how and elegant this solution to do, working out the directory size is. This is one of the main benefits of recursion, is because we get these really nice, elegant solutions to a problem. So, if the file is a directory, get all the files that are contained within this directory, and then loop over them, calling getSize to get their size. So this takes care of any subfolders, because this will be handled with this block of code. The subfolders will be handled just with this. However, if it's not a directory, then we use this. We get the length of the file, which returns the number of bytes of the size of the file, and we just add it onto the word size. Finally, we return size. So really, that's the bulk of this video done. What we should probably do now is create a main method to test it. So, public static void main string array args. Alright, what we're going to do here is ask the user to enter a path to a folder. So, system.out.print, enter a directory or file. Alright, so now what we're going to do is use scanner to read in what they entered. So scanner input equals new, scanner reading from system.in. Okay, so now what we're going to do is declare a string called directory, and we're going to just read in the next line from the scanner. So input dot next line. Okay, so now what we need to do to display the size is use this getSize method. So system.out.println get size. Now remember that getSize. Oops, this shouldn't be in a string. My bad. GetSize. Remember that getSize, the parameter, is a file, so we need to create a new file here, and we can just pass in the string that they entered. Okay, so there's our new file. There's our getSize. So what we're going to do is add bytes to the end of this, so it'll tell us that's how many bytes it is. All right, that's our program done. So let's try and test this now. So run as. Actually, before we run it, what I should do is show you guys what I've actually got ready to go here. What I've done is created this small directory structure which has basically just some images in it. So the reason I did this is because we've got some images here in the top level directory, and then we've got this subfolder called camera, and inside here we have some more files and also another subfolder with some more files as well. So we've got this directory tree that we can use. So what I'm going to do is just copy that path, and now back in Eclipse, let's run this. Run as Java application. Okay, enter a directory or file. What I'll do is just paste in the path of the images and hit enter. Now, what has it said? It said 43,283,578 bytes. In other words, 43-ish megabytes. Now, is that correct? Well, how do we know? Well, the way we can find out really easy is see what Windows said it was. So Windows is saying, now the important thing is here we're rounding, but what we're interested in is the size on disk. And it's not quite the same, but it's pretty close. So what's happening here is there's some discrepancy between the overhead, because storing files on a file system is not free. It takes up some extra space to be able to do that. So one of these is reporting all of the space and one of them isn't. But you can see they're very, very, very close, which is good enough for me. The point is there's both, say, 43 megabytes, which is fine for our purposes. So with that, that's really all there is to this video. So quickly to summarize, what we did in this video was we found the total size of a directory. And to do this, we had to add together the size of all the files and subdirectories that a particular directory contained. The directories have to be recursively descended into to find out their size. So if we have subfolders, we need to descend into them recursively to make it work. Now, just finally as an implementation note, a file object is used for both regular files, directories, and links if you're on Unix type systems, such as Linux or Apple. You can use the isDirectory method in file to find out if a file is actually a directory, and we had to use that here to work out whether we needed to list the files or just add the size. So with that, that's it for this video. Thanks a lot.